Hey everyone, welcome back to our TxePrep video, and in this video we're going to look at the USACO 2021 US Open Bronze Contest, problem number 2, Acowdemia 2. So let's just read this problem and see what it's trying to say. So Bessie is applying to computer science graduate school and has secured an interview at the computer science lab, but she wants to determine the relative seniority of the n current members of the lab, where n is between 1 and 100, but she realizes that determining their seniorities may be tricky, and she determines the seniorities by looking at the publications. So each publication will contain an author list, which is an ordering of all the n lab members, and it's in decreasing order, so based on the effort that each lab member contributed. And if multiple researchers put in equivalent effort, they're ordered alphabetically. But since the more senior lab members have other duties to do, a senior researcher never puts in as much effort as a junior researcher, meaning that a junior researcher will be ordered before a senior researcher on the publication of the author list. So for example, in this case, let's say we have a junior Elsie, kind of like a middle Professor Mildred, and a very senior Professor Dean. So we have over here that Elsie, Mildred, Dean. And this basically means that Elsie would put in more amount than Mildred would put in a medium amount compared to Dean. And if Mildred and Dean put the exact same amount, we'd have Elsie, but then these would be ordered alphabetically, even though they're different in seniority. So given K publications of the lab, help Bessie determine for all pairs of researcher who is more senior if it's possible to tell. So the first input is K and N, and we also have N, basically just the names, and then we also have K, basically K lines of publication order, like publication and the author list of each one of them. And based on those, we're supposed to figure out seniority. So in order for the output, every character in the diagonal should be just B, because a person cannot be more senior than themselves, but the other ones should be, for example, this is row 1 and this is column 2, so that means the researcher at index 1, which is Dean, is more senior than the researcher at index 2, which is Elsie, right? So that's basically what this means. And we can also say the same thing for the next one, where it's like the researcher at row 1, column 3, so that means Dean is more senior than Mildred. But we can see over here that Elsie would be less senior than Dean, but we're not sure between the seniority of Elsie and Mildred, since they're ordered alphabetically, and we don't have any other data to go off of. So let's just start programming this and see what happens. So obviously our first step should be to include everything, so I'm going to do include bits standard c++.h, and I'm going to use namespace standard. And then what I'm going to do is create our int k and n, basically our inputs, and then also we have to create a map, and this map is going to be used to store the index at which the names occur. So for example, Dean would be stored at index 1, and Mildred would be stored at index 3. So that kind of storing. So string and then int, and what I'm going to call this is just names, and this basically represents the name followed by the index. And what we have next would be a character array of the answer, which would be a size 101 by 101, considering the fact that n has a maximum value of 100. So that basically just be our answer, which is our grid of whether we know the seniorities or not. So now is time for our main function, and I'm going to input k and then n, and then after that I'm going to input the strings, basically all the names. So for int I is equal to 0, I is less than n, I plus plus. Oops, I is less than n, I plus plus. I'm going to input the names, so I'm going to create a dummy variable x, input that, and then put that in our map. So I'm going to say names at x is equal to I. So just mapping the index to the name. And next, what I'm going to do is initialize the answer over here, and I'm going to transfer these like B's across the diagonal and question marks for everything else. So the way this is going to work is as such. So if j is equal to I, then we know for a fact that it's in a diagonal, so I can just say the answer of ij is equal to b. And otherwise, I know that it's the two distinct pairs of researchers, so I'm going to say question mark. And then based on that, basically we can look at every single pair and then figure out whether a pair can be solved or not, and assign it an answer. So that's what we're going to do now. So first of all, I know that I'm going to have k publications. So as you can see here in the second input, I have 2 publications. So I have 2 publications over here, so I need to account for that. So I'm going to say int I is equal to 0, I is less than k. Int I is equal to 0, I is less than k, I plus plus. And now what I'm going to do is create an array. I'm going to call it cur. So what this means is simply just all of the names in each publication. So for each publication, there'd be a different array. So it would have a maximum size of 101 because n has a maximum size of 100. And I'm going to input that. So for int j is equal to 0, j is less than n, j plus plus, cn cur of j, right? And then I'm just gonna loop through every single ordering of the researchers in each publication. So for int x is equal to 0, x is less than n, x plus plus, and I'm gonna set a flag which basically means like bool is alphabetical. And the reason I'm doing that is to see whether two pairs of researchers are in alphabetical order or not, and if they're not, then we know that we have to check their seniority. So I'm going to say this is, I'm going to start it off as true and then check later on whether it's true or not. And then, so for int y is equal to x plus 1, so basically, and I'm going to go through every single pair, y is less than n, y plus plus. And by pair, I mean, for example, in this case, where I go Elsie, then Mildred, then I check Elsie and Dean, and then I check Mildred and Dean. So that's basically what I mean by the pairs. And now what I'm going to check is whether they're alphabetical or not. So I'm going to do for if cur of y minus 1 basically means that the previous one of y, so if cur y minus 1 is greater than cur y, basically means that the previous value of y, the previous value from the current name of y is not alphabetical, then we know that there's a difference in seniority. So I'm going to set the flag is alphabetical to false. And now, since I know that it's not alphabetical, I'm going to create a specific is alphabetical. Now what I'm going to do is actually find the indexes and then assign the values to the array and whether they're senior or not. So I'm going to call int a is equal to names of cur x, and b is going to be equal to the names of cur y. So basically just the two names of the researchers. And I'm going to assign as answer at a comma b to be equal to 0. And the reason I'm going to assign it to 0 is because, the reason I'm going to assign it to a comma b is because a is basically the name that it comes from x, and x comes before the name of y, and that means that x would be more junior than y no matter what, since it comes before, and they're not alphabetical. So based on that, I can assign this to be 0, and I can assign the opposite, basically answer at b comma a, to be 1. And now that I have that, I basically just completed filling my array based on whatever I know, and I can just output it given with all the question marks that are still remaining. So now for int I is equal to 0, I is less than n, I plus plus. For int j is equal to 0, j is less than n, j plus plus. I'm gonna output the array, answer at I, j, and then what I'm gonna do after that is output the answer at output an n line, basically just to create like a white space, just to create a new line. So now let's actually run this and see what happens. So I'm gonna copy this, I'm gonna paste it, and we do get the array that we're desiring. So let's just try the other one and also see what happens. In this case, I'm gonna take this and run it, and see what happens. And we do get the array we desire. So now let's actually submit it and see what happens. So here I am about to submit the solution. So let's see what happens. Yep. So it's grading right now. So it seems like we're getting all the test cases, and we do actually get all the test cases, and it looks like it works. So basically, in summary, what we did over here was we created a map. We obviously input everything, but then we created a map, and we basically mapped the names to individual indexes, and we basically pre-initialized the answer array through all question marks, and obviously B in the case where it was a diagonal. And then what we did was we looped through every single pair for every single test case to see if we could determine whether or not two pairs of researchers had a difference in seniorities. And then if we could determine that based on their alphabetical ordering, then we updated that in our answer array and then output at the end. So I hope you guys enjoyed this video, and I'll see you guys in the next video.